In our previous lesson, we have considered rational functions. We have considered how we can simplify rational functions, which are functions that are of the form p of x all over q of x, right? And that is equal to probably f of x. And we said that to be able to simplify that, we must ensure that we factorize the numerator of the expression, factorize the denominator, and cancel out common factors. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to consider how we can express rational functions by actually simplifying them whilst we add and subtract. So let's consider this example. So the example says that given that f of x is equal to 2x minus 1 all over x minus 2, and g of x is equal to x minus 3 all over x plus 3, find f of x minus g of x, and then f of x plus g of x. So now let's look at how we can solve this question. So to solve this question, let's ensure that we write out our functions. So our functions include f of x, which is equal to 2x minus 1 all over x minus 2. And then it has g of x, which is equal to x minus 3 all over x plus 3. Now we have to find the first part a, right? F of x minus g of x. So let's try the expressions out. So our f of x is 2x minus 1 all over x minus 2. And then we bring the minus sign. And then we have x minus 3 all over s plus 3. So we go through this process the same way we go through addition, probably, and subtraction of fractions. So when we are adding and subtracting fractions, the first thing we do is to find the LCM. So realize that the LCM of s minus 2 and s plus 3 of the denominator will be x minus 2 and s plus 3. Then realize that x minus 2 goes into x minus 2, right? So it cancels out, we'll be left with s plus 3. So we take the 2x minus 1 and multiply it by s plus 3. Then we bring the minus sign, and then in this case s plus 3 cancel out s plus 3, so we have x minus 3. In this case, multiplying the expression s minus 2. Right, so now that we have this, we can write this expression. We want to expand, right, and write it as 2x s plus 3, right? And then we bring the minus sign. We can bring a bracket, x minus 2. Okay, so we have 2x plus 3. We have to bring the second term, right? So this 2x, what happens is that it multiplies the second expression here, right? And we can take the negative 1 to multiply the second expression here. So we have minus 1, right, multiplying x plus 3. And we have minus, right, brackets x minus 2, and then minus 3 x minus 2, right? So we can close the brackets here. And then now we have our denominator, which is the LCM, x minus 2 and then x plus 3. So we want to expand the numerator part. So we are going to have 2x squared plus 6x when we multiply 2 times 3 with the x. Then minus 1 times x gives us minus x. Minus 1 times 3 gives us minus 3. We have, right, the negative here. So let's bring our bracket out. X multiplying x gives us x squared. S multiplying minus 2 gives us minus 2, right, x. And then we have minus 3 multiplying x gives us minus 3x. Then we have negative gives us positive. 3 times 2 gives us 6, right? And all these all over x minus 2 and then s plus 3. So the negative affects everything in the bracket, so we can write it as 2x squared plus 6x minus x minus 3 minus s squared. Negative negative becomes plus 2x. Negative negative becomes plus 3x. Then negative positive becomes minus 6. All this over x minus 2 and then x plus 3. So here we can group like terms. So all those terms with a square, we can have 2x squared, right, plus, right, so we have 2s squared, which is the s squared term, right, so we can have minus, right, x squared, right, then we can have plus 6x, right, then we can have plus 2x, right, and then we also have plus 3x. So these are all the x terms, right, and then we can also have the constant term, which is minus 3, and then we have minus 6 as well, right, so we have the constant term minus 3 and minus 6, right, so all this over x minus 2 and then x plus 3. So for that, basically we are going to get s squared at the numerator part, 6s plus 2x plus 3x, right, minus x. So there's a minus x before the minus 3 minus 6. So we have minus x minus 6 minus 3. So 6s plus 2x gives us 8x, right? And then 8x plus 3x gives us 11x. 11x minus s gives us 10x. Right, so we get plus 10x minus 9 all over x minus 2 and then s plus 3. So we've simplified the expression, right, into a simplest form. So therefore we say that f of x minus g of x, right, is equal to s squared plus 10x minus 9 all over x minus 2 s plus 3. So we see in the second part of the question, we have to simplify f of x, right, plus g of x. So we want to simplify f of x plus g of x. So f of x plus g of x. So this implies that we are going to have our f of x, which is 2x minus 1 all over x minus 2, then plus x minus 3 all over x plus 3, right? So we are going to have, right, the LCM in this case being x minus 2, then x plus 3. So we go through the same process. It means that here we are going to have 2x minus 1, right, x plus 3, and then plus x minus 2, x minus 3, right? So we are going to have f of x plus g of x to be equal to 2x s plus 3 plus, right, so in this case we have 2s x plus 3, and then we have negative 1, right, which is here, negative 1 s plus 3. Then on the other hand we have plus x minus 3, and then minus 2 x minus 3. Then all this over the LCM, x minus 2 and then x plus 3. So let's expand the numerator part. So our f of x plus g of x will be equal to 2x squared plus 6x, right, minus x minus 3, right? So we are going to have plus x squared minus 3x minus 2x plus 6, right? So all this over x minus 2 and s plus 3. So we have our f of x plus g of x to be equal to, let's group like terms. So in this case we have 2s squared plus s squared plus 6x minus x minus 3x minus 2x minus 3 plus 6 all over x minus 2 and then x plus 3. So once we have group like terms, if we want to simplify this, it means that we will have our f of x plus our g of x to be equal to 3x squared. 6x minus x will give us 5x, minus 3x will give us 2x, 2x minus 2x will go to 0, So minus 3 plus 6 will give us, right, plus 3 all over x minus 2, right, and s plus 3. So therefore we get our f of x plus our g of x to be equal to 3x squared plus 3 all over x minus 2, x plus 3, right, x minus 2, x plus 3. You can even further simplify this by writing the expression, right, as 3, we factorize 3 out, then we have x squared plus 1, right, all over x minus 2, right, x plus 3. So this is f of x plus g of x. So we have gone through the process of actually trying to simplify expressions by adding rational functions and subtracting rational functions, and we've seen that to be able to add them, we must go through the same process as what we do when we are adding and subtracting fractions. We find the LCM and then go through the process of simplifying it. In our next lesson, we want to consider how we can decompose rational functions. We want to look at how we can separate rational functions and write it in forms that we can use for so many things. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.